Today we're going to be looking at percent composition, which by definition is the ratio by mass, so by how much weight, of the elements within a compound. So we're going to be calculating percents here using the mass of different elements within a compound. And from those masses that we are either given or we can calculate, we can determine the percent of that element that makes up a whole compound. So to keep it simple to start, let's look at a sandwich. Now here I have a sandwich. We can see how many pieces of each ingredient there are. And let's just give some basic numbers here. Let's say that each slice of bread is 20 grams. Let's just say that. Let's say the tomatoes are 15 grams, the cheese is 10 grams, and the lettuce is 5 grams. Let's just keep things very simple to start. Now, what we can see is that if I want the total amount of bread, each piece of bread is 20 grams. But that does not mean that the bread itself is only 20 grams because there are two slices of bread here. Here's a slice of bread here, and here's a slice of bread here. So we need to account for that when we calculate percent composition. So the bread, it's not just 20 grams, it's 20 times 2 because there are two slices of bread. We could do the same thing for all the remaining ingredients. For the tomato, there are 1, 2, 3 slices of tomato. So we multiply that by 3. There is 1 slice of cheese, multiply that by 1, and there is 1 lettuce leaf. So we multiply that by 1. And in doing so, we get the mass of each individual piece, each individual component, of the sandwich. So bread, 20 times 2, that is 40 grams worth of bread. The tomato is 15 times 3. The tomato is 15 times 3, which is 45. The cheese is 10 times 1, which is 10. And the lettuce is 5 grams times 1, which is 5. So those are the masses of each individual piece. And if we add them all up, we should get the total mass of the entire sandwich. So if we add them up, that's 40 plus 45, that's 85, plus 10, that's 95, plus 5, that's 100 grams. This is what we've been doing, or very similar to what we've been doing when calculating molar mass. Right? If we think to molar mass, we look at the molar mass, we multiply it by how many of that individual element are in the compound, and then we get the sum of the result. That's very similar to what we're doing here. So think of this as the molar mass for the sandwich itself. Now for percent composition, we have this equation right here. The percent composition is equal to the mass of the part divided by the mass of the whole. That is percent composition. So what we need each part, and we're going to divide it by the whole compound and then multiply by 100. That's how we make it a percent. So the parts, that's this. These are each individual part. The whole is this big number here. So what we're going to do is we're going to take those numbers and set it up in this equation, and then we should figure out the percent composition of each piece. As an example, here's my 40 grams of bread. If I want my percent composition, it's going to be the 40 grams, that is the bread amount, divided by 100 grams, because that's the total, that's the whole compound, that's the whole sandwich, and then we multiply that by 100. And when we do that, we get 40%. We can do this for each piece. So for the tomatoes, we have 45 grams worth of tomatoes. Now I am looking at all of the tomatoes together. I'm looking for the percent composition of tomato. How much tomato is in this sandwich? Not how much in each individual tomato takes up. That'd be a different question. But for all of the tomatoes, that's 45 grams divided by 100 grams, the total mass of the sandwich, times 100 equals 45%. Rinse and repeat for each of these substances. 10 grams for the cheese divided by 100 grams for the substance times 100 equals 10%. Lettuce, 5 grams of lettuce divided by 100 grams of the sandwich times 100 equals 5%. Very straightforward calculation. When we do this, we should end up with a total 40 plus 45 plus 10 plus 5% that equals 100%. So any of these calculations, the sum of all percent compositions should equal 100%, or very close. If you get 99.99 or 100.01, that's close enough, right? Sometimes with rounding, we're going to end up a little bit off, but if you end up adding all of your percent compositions and you're only at like 95%, or you're at 112%, somewhere some of your math went wrong and you're going to want to go back and double check. Let's look at what this looks like for compounds. So here's an example. I have C6H12O6, which in case you didn't know, that's glucose. It's a type of sugar. What we're going to do is we're going to find the mass of each element and the whole compound. Very similar to what we just did with the sandwich. So I'm going to look for the mass of each individual element. Now, in order to find the mass of each element, we're going to need to look at our periodic table. So if you don't have your periodic table out right now, I would grab your periodic table. Pause now, grab your periodic table. For those of you who do have your periodic table, let's take a look for carbon first. The molar mass for carbon is 12.01 grams per mole. The molar mass for hydrogen, let's look for hydrogen now. The molar mass for hydrogen is 1.01 grams per mole. Finally, let's look for oxygen. The molar mass for oxygen is 16.00 grams per mole. However, that is only the molar mass for each piece individually. It does not include all of the carbons or all of the hydrogens or all of the oxygens in the compound. So in order to get that, we have to multiply by the number in the compound. That's where those subscripts come in. We're going to use those subscripts to determine how many of each element are in the compound. So for carbon, 12.01, we're going to multiply it by 6 because there are 6 carbons in the compound. And that gives us a new total of 72.06. For hydrogen, there are 12 hydrogens in the compound. So we're going to multiply by 12, and that gets us 12.12. Oxygen, there are 6 oxygens in the compound. So we're going to multiply that by 6, and we get 96.00. So when we add all of these up, that's going to be what gets us our total. So 72.06 plus 1212 plus 96.0 is 180.18. That is our total mass for the whole sugar, the whole glucose compound. What we're going to look for is the percent composition. And just like we did earlier, for the percent composition, we're going to need the mass of the element divided by the mass of the whole compound, and then we're going to multiply that by 100 in order to make it a percent. So for this, you are going to need a calculator because the setup here involves this number that we've just calculated as well as this number that we just calculated. So it's going to involve the 72.06 and the 180.18 for carbon only. So let's set up the percent composition for carbon. 72.06 divided by 180.18 times 100. This should give us our percent composition. And if we do that math, 72.06 divided by 180.18, and we multiply that by 100, we should get 40.0%. Let's do that for the other elements as well. Hydrogen is 12.12 divided by 180.18 times 100 equals 12.12 divided by 180.18 times 100 equals 6.73%. Oxygen is 96, because we want to include all of those oxygens. 96 divided by 180.18 times 100 equals 53.3. And if we add up all of those total percentages, 40.0% plus 6.73% plus 53.3%, we end up at 100.03, which is close enough to 100%. Like I said, this rounding for this one having 3 sig fig, for all of our numbers having 3 sig figs, is going to affect that 100% a little bit, but it's 100.03. We're not that far off of 100%. That is good enough to say that we're at our full percent composition. Go ahead and pause here and give H2O a try. I'll leave the example we just did up, but go ahead and give H2O a try, and we'll go through it here. All right, let's go through H2O. So for H2O, hydrogen was 1.01 grams per mole. Multiplied that by 2 to get 2.02. Oxygen was 16 grams per mole times the 1, because there's only 1 in the compound, so we get 16.00. Our total is 18.02. So to find the molar mass, to find the percent composition, it's going to be the mass of the substance, 2.02 for hydrogen, 16 for oxygen, divided by 18.02, because that is the mass of the compound. Then we multiply that by 100 to make it a percent. And the percent composition for hydrogen is 11.2%. And for oxygen, it is 88.8%. And this one does work out to be 100% in total, so we know that we're in the clear. So let's give some of these other problems a try, because these ones are pretty easy. Just find the percent composition. It's a little bit more challenging when you see it in word problem form. As an example here, the first one, an unknown substance with a mass of 87.3 grams is identified. It is found that 17.3 grams are made of hydrogen and 50.0 grams are made of carbon. What is the percent composition of each element? Now, if you notice, I've given you this GUESS, this guess method setup. I tend to find it's very handy when it comes to solving problems like this, especially these word problems, because it allows me to organize the information a little bit better. So, as a recap, guess. G stands for given, so the given information within the problem itself. U is for unknown. What are we looking for? What are we trying to find? E is for the equation, which I have already given you here. It's the percent composition equation. That's what we're using for these problems. S is for substitute, and then the second S is to solve. So we substitute all the numbers that we have into the equation, and then we're going to end up solving it using our math skills. So for this problem, for our first step for our given here, for G, right? I want to look at what actually in the problem do I know. So important things are usually numbers. Numbers are a good call of what's given. So as an example, mass of 87.3 grams. That is the mass of the whole substance, or the total mass. It is found that 17.3 grams are made of hydrogen. Well, that's great to know, because then that's just the piece that's equal to hydrogen. And 50 grams are made of carbon. Those are our given pieces of information. Our mass is 87.3 grams, 17.3 grams are made of hydrogen, and 50 grams are made of carbon. The unknown is what we are actually looking for. Now, the question is asking us, what is the percent composition of each element? So we are trying to figure out, hey, of all of our elements, what is the percent composition for each piece? So from there, now I can actually use my equation and start setting things up. So I'm going to set up all the hydrogen stuff next to the hydrogen here and all the carbon stuff next to the C. So for hydrogen, we know that we have 17.3 grams. So I'm going to use this percent composition equation and solve it for hydrogen. I want to find the percent composition of just hydrogen. So for 17.3 grams of hydrogen, we know the mass of our whole compound is 87.3 grams. Then we multiply that by 100 because that is what gives us a percent. So 17.3 divided by 87.3 times 100 gives us a percent composition of 19.8%. Same thing for carbon. We found that carbon, or we were told that carbon, is 50 grams of the whole substance. So we're going to set up the same equation, but now instead of using hydrogen, we're going to use carbon. So the mass of carbon is 50 grams divided by 87.3 grams times 100. That gets us to a percent composition of 57.3%. Now, I know what some of you guys are thinking. You're going, wait a minute, that doesn't equal 100%. And you're right, it doesn't. But if we take a look at our grams that we were given, our grams of hydrogen, our grams of carbon, that also does not equal to our total mass of the unknown substance, which means there's probably another element in here. So that's something to keep in mind, that we don't always want to use that 100 grams as like gospel. It's a good checking method, but it's not something we can actually go to 100% of the time without fail. It doesn't always work. It's just a good way of double checking if you know you have all of the elements given, like in the first two examples. Let's give the next two a try. These ones are going to be a little bit different, but we'll give them a try. So the next example, a compound is 62.5% nitrogen. In a 30-gram sample of the compound, how many grams of nitrogen are present? So this one has, some different given information, but same concept. So here's our givens. We have numbers here, right? 62.5% nitrogen, 30-gram sample. That's all that's given for us. That's okay because it's only asking us about nitrogen. The unknown, what we're solving for, how many grams of nitrogen are present? So we're looking out of this 30-gram sample. If we know that 62.5% of that sample is nitrogen, how many grams is that equal to? So in order to solve this problem, we're going to need this equation, but we're going to set this up a little bit differently. We know the percent composition. The percent composition is 62.5%. What we don't know is the mass of the element. So I'm going to leave N alone because that's what we're actually looking for. What we do know is that the compound sample is 30 grams. Multiply by 100 because this is a percent. So the first thing I'm going to want to do here is probably divide both sides by 100, right? Get rid of this 100. That's not really a part of the equation we really want to deal with here. So when I do that, 62.5% divided by 100 gets me 0.625 equals N divided by 30 grams. So now I want to get N by itself. So in order to do that, I got to do the opposite operation. Think about that for a second. 30 is being divided, so we got to do the opposite. Opposite of division is multiplication. So we're going to multiply both sides by 30 grams. So if we do that, 30 grams and 30 grams cancel out. Division, multiplication, those cancel. So then we get nitrogen, the amount of nitrogen is equal to 30 grams times 0.625, which gives us a total of 18 0.8 grams. Seems reasonable, right? 62.5, it's a little over half. That's 18.8, that's a little bit of over half of the 30-gram sample originally. That number seems perfectly logical. All right. Go ahead, give this last one a try here. A compound is discovered to be made of oxygen and sulfur. The percent composition of the compound is 60% oxygen and 40% sulfur. How many grams of each element are present in a 42-gram sample of the compound? So take a minute, work through the problem, see what we get, and then we'll compare answers in just a little bit. So pause here, go ahead, give the work, and then we'll walk through it here in just a second. All right, let's give this a try. So first, given information. What numbers are given to us? Well, we'll try that it's 60% oxygen, 40% sulfur. We're also told that it has a 42-gram sample. That's our given information. All those numbers that are given to us, I'm also highlighting what they are, whether they're percent, grams, and what of that they are. 60% oxygen, that's my percentage of oxygen. 42-gram sample, that's the whole thing. That's oxygen and sulfur together. Our unknown, what we're looking for how many grams of each element. So we're figuring out how many grams of each element are in this total compound. So this problem is very similar to the problem above, but we're going to end up doing things twice. Once for oxygen, once for sulfur. So starting with our oxygen, percent composition is 60%. We do not know the mass of oxygen, but we do know that the mass of our compound is 42 grams. And then we multiply by 100 because this is a percent. If I divide both sides by 100, I get 0.6 is equal to, it's a decimal point there, oxygen divided by 42 grams. So I'm going to multiply both sides by 42 grams. In order to cancel, 42 on top, 42 on bottom, those cancel. So our percent composition of oxygen is 42 times 0.6, or 25.2 grams. Sulfur, we're going to do the same thing. 40.0% equals sulfur. We do not know the mass of sulfur. Divided by 42 grams times 100. Divide both sides by 100 to start, just to get rid of that percentage and get rid of that 100. So 0.4 is equal to sulfur divided by 42 grams. Multiply both sides by 42 in order to cancel that out. 42 on top divided by 42 on the bottom. 42 grams specifically, excuse me. 42 grams divided by 42 grams. Those cancel. So our sulfur component is equal to 42 grams times 0.4, or 16.8 grams. And since our percentages added up to be 100%, our total masses should add up to be 42 grams. So 25.2 plus 16.8 does get us to 42. So that is percent composition. It's really all about looking at the percentage that a single element makes up a whole compound. And as long as you can calculate a percent, part over whole times 100, you'll be just fine for all the calculations here. If you want to go ahead and get started on Moodle Unit 7 Assignment 4, that is all percent composition based.